Hi guys, in this video we're going to talk about the mole and how to find the molar mass of an element. This video is made specifically for our Unit 5 where we did talk about finding the molar mass of compounds in Unit 4, but we're just going to really focus in on the elements this time. So let's get out our handy Cornell notepaper. So make sure you put your name, date, and class period here, and our objective is the mole and molar mass, and we'll be answering two essential questions. The first is, what is a mole? And the second question is, how do I find the mass of a mole? Okay, so let's move this down a little bit. Okay, so the first thing we're going to start with is defining the mole. A mole is a set of 6.02 times 10 to the 23rd of something. So you're familiar with a dozen. A dozen is 12. A gross, if you've ever heard of that one, is 144 of something. If you have a dozen eggs, you have 12 eggs. If you have a dozen textbooks, you have 12 textbooks. If you have a dozen people, it would be 12 people. A mole is like a dozen in that if you have a mole of something, that's how many you have. If you have a mole of people, you have 6.02 times 10 to the 23rd people. If you have a mole of donuts, you have 6.02 times 10 to the 23rd donuts. A mole is simply a set amount of something, okay? Now, we use the mole to help us think about particles. You see, since particles are so stinking small and we can't see them, we use a mole to help us think about how many there are. And you might be asking, how are we able to know that that's the right number of moles? Well, there was this guy named Avogadro, and he did some experiments to determine this number of moles. If you'd like to look that up, that's a great idea. I can't really explain it to you very well, but Avogadro figured that number out, and it's called Avogadro's number. In fact, sometimes it's abbreviated N with a little subscript A for Avogadro. So that's how many particles are in a mole. If you have a mole of something, that's how many particles you have. Now, the interesting thing about mass is that when you talk about the mass of a mole, you're talking about the molar mass, and the molar mass depends on the size of the atoms that you're talking about. For example, if you had a dozen people and a dozen donuts, a dozen people is going to have more mass because each person has more mass than each donut. The same thing is true with atoms. If you have a mole of this light atom and a mole of the heavy atom is going to have more mass. So when we think about things, we always talk about the molar mass of something. Now, for elements in the periodic table, the molar mass is super easy. Okay, so this right here is the key that you would see on your periodic table that tells you what all the things that are on the periodic table mean. It's got an element name, the atomic number, which we talked about in Objective 3, and it's got the symbol, and then there's this thing down here that says atomic weight. So that atomic weight is actually, that's a useful number. That tells you the mass in grams. Oops, I didn't get my G far enough away. The mass in grams of 1 mole of something. So that right there is the molar mass. So for example, oxygen, that number is 15.999. That means that each mole has 15.999 grams per mole. Now that 15.999 is another useful thing that we'll talk about in the next objective, or maybe it's objective 5, I'm not really sure, or 6. But this molar mass right here is what you need to know. So if you need to know the mass of 1 mole, then you would just look it up in the periodic table if it's an element. Now we'll talk about what to do when it's a compound again in our next unit, Unit 6, but it's really easy. You just add up the pieces of the compound. All right, so that's a blurb about mole and mass and how to find the molar mass of elements on the periodic table. Thanks for watching.